PSN College of Engineering and Technology in Tirunelveli. Today we are going to discuss about the composite materials. So before going to enter into the topic, let me discuss about the definition of composites. What's a composites? So this is nothing but two or more materials combined to make a single component. For example, I will say some quite interesting example for the composite materials. So see our human body. So human body is one of the composite material best example for composite materials. So here our bone is a reinforcement materials. An outer layer of tissues is a matrix material. So combine these two materials to make our human bodies. Like that way, the composite materials make two different materials, which is one of the reinforcement as well as matrix, to make a single component. So the particular single component it may be differ for the different applications. So some of the applications need thermal properties. So it may be possible to make a composite with through the temperature resistance materials. So some of the applications need a wear resistance. So that is also possible from the composite material. So this is one of the favorite and most interesting of the key parameters for composite materials. So next one is designed to achieve the superior properties not attainable by the individual constituents. So next, classification of composite materials. So here I already told the two main components. One is the reinforcement and as well as matrix materials. So here the reinforcement materials is differ for the different to enhance the different properties. So first one is fibers, and next one is ceramics, and next one is metal matrix. So these majorly classified for the reinforcement materials. So some of the fibers reinforced materials means, so see the PPT, so the glass fibers, carbon fibers and aramide and some of the natural fibers. So these are all the fibers, so which is used in the composite as a reinforcements. So here the glass fiber and carbon fiber is a synthetic fiber. Okay, why it is called as a synthetic fiber? Synthetic fiber means, so the people are prepared or developed these fibers by the manually. But the aramide fiber and natural fiber is a natural biodegradable materials. So these is available from the natural waste from the plants, from fruits, from stems. So all the categories are collected from the natural fibers. See, one of the quite interesting of aramide fiber application is armor shield, which is used in the defense applications. So this is one of the quite interesting of the aramide fiber. So the next one is carbon fiber. So the carbon fiber is mostly used in the aerospace applications or some other defense vehicles also, because its main advantage is very low weight with high resistance, impact resistance or tensile resistance, some other resistance. Okay. So next is the fiber orientations. So before going to see the fiber orientations, let me know about the unidirectional woven and randoms. So what is the unidirectional woven and random means? So based on the fiber, so last we seen the glass fiber, carbon fiber and aramide fiber. So if it's by manually made, for example the glass fiber and carbon fiber, we can able to develop the fiber. So the length of the fiber and diameter of the fiber we can able to control. But what about the aramide fiber and what about the some other natural fiber? We can't control the length as well as diameter. So because these two is naturally available, what are the we get it from the source. So here the fibers are classified based on the length of the fibers. For example, if it is more than 2 centimeter or more than 5 centimeter, the particular fiber called as a long fiber. If it is a 5 centimeter, less than 5 centimeter is a chopped one. So if it is less than 1 mm, it is called as a particulates. Okay. So based on the length, it may, and the fibers may be differ. Okay. So next come to the points, fiber orientation. So the fiber orientation, the unidirectional means, so only applicable for the long fibers, the unidirectional. So it is arranged in the it is arranged for the uniform structure. So first one is a linear, and second fiber is also linear, and third fiber also linear. So for example, our mat, sleeping mat. So sleeping mat, natural mat. So natural mat is made up of the unidirectional materials. So next one is a woven. So woven is our floor mat, our food mat. Food mat is our one of the example of woven mat. So because there is a spin to the cross multiple. So one is a linear and another one is a vertical. So these is a woven categories, and last one is a random. So random means our pillow. Okay. So our pillow is one of the random application, random fiber filter applications. So the inside of the pillow, the cotton materials randomly spread over the cover, pillow cover. So it is called as a random orientations. Okay. I hope everyone understands what is the fiber, what are the types available in the fibers, and next one is the fiber orientations. So next one is the matrix material. So this is very very important for the composite materials, because the matrix material to give the structure of the composite materials, like the way our tissues. So our tissues is supporting material of the reinforcement materials. So here see the polymers. I already told the classification of the composite materials. So one is a polymer, and second one is a metal, and third one is a ceramics materials. So see the first material, polymers. So thermoset and thermoplastic. So here they are using two different types of polymers, matrix materials. So what is the thermoset and what is the thermoplastics? So thermoset is a simply I said there is no reusable materials. So that's a one type of single time use only. So but the thermoplastic is you can able to reproduce and recycle of the, once the life cycle is completed on the thermoplastic component, we can able to regenerate the particular composite. Okay. So the metal, so mostly the aluminum and magnesium material used for the matrix as a metal combinations, metal composites. And next one is a ceramic. So ceramic in the case, maximum silicon carbide aluminum dioxide is used for the matrix material for to develop the ceramics materials. Okay. So we discussed what are the raw materials and how it is look like, what are the nature of the raw materials. So everything we have discussed. Next is something different. So how to develop the composite materials. Okay. So before see the slide, let me see the images. So see the first image A. So there is a hand layer method. Okay. So it is called a hand layer method. The entire composite material developed through our human being only. So the pouring is also. So see the cup here, the resin, thermoset resin pour onto the die. So see the dark block. So the dark block is our fiber material. So above the fiber material, the liquid resin will be poured. So next, the uniformly spreading the resin over the fiber with the help of the roller. Okay. So the roller will move on the fiber material. Plus I will apply our hand force also. So automatically the resin will impregnate into the fiber material. Okay. So after 3 hours or 12 hours, it's a curing time. Okay. So for example, curing time is depends on the material. So polyester. So polyester is one of the classification of the thermoset matrix material. And epoxy is another classification of thermoset matrix material. So what's the difference between the epoxy and polyester means? So polyester is a vinyl based material. Okay. Okay, so in curing time take a 3 hours or maximum 3 hours or 4 hours. But epoxy is take a 12 hours it need curing time. Okay, so next B category. So see the B category. B is somewhat advanced from the hand light method. Okay, so here we can control the thickness of the materials, as well as we can be able to develop some different layer stacking composite materials. See the image. So first one is one material, and second one is another material, third one is another material, fourth one is another material. So these four materials stacking onto the die material. Okay. So after that we can we can add to the matrix. This means epoxy or polyester or vinylation, so something to pour on the die materials. Okay. After that it may be closed. Okay. So the closed means maximum pressure applied onto the composite material. So in a closed medium, after 2 hours or 12 hours, it's based on the matrix material conditions. Let me get the proper uniform thickness and uniform distributions of the epoxy material or the polyester material. We can able to control the thickness and orientations, everything. Okay, and another advantage is we can develop the composite material in any kind of structures. Okay, so next one is a C. So this is a resin transfer molding machines. So this look like a linear horizontal, and another one is a linear material. So we can we are going to fill the fibers on this gap. Okay, so next we are going to inject the resin through this port also. Okay, so here some of the for this compression molding machine, some other blowholes or voids may be available. Okay, but here we can control the voids or blowholes may be controlled through the resin transfer molding, because so these two vent also available, but here there is no vent. Okay, if suppose we are open the vent here, means once while we are applying the load on the sample, all the resin materials will pour through the vent, so we can't control the volume of resins. So here the vent will be open, so we can control the voids and bubbles. We can able to control through the vent port, Okay, so automatically the vent control. So the next one is injection molding. So the injection molding is purely based on the thermoplastic matrix material. So because these A, B, C is a liquid resins, so these three cases only for the thermoplastic matrix material. But here thermoplastic purely based on the thermoplastic materials. So see the hopper. We have the thermoplastic material generally available in the granules. Look like a small box. Okay. The small balls will loaded on the hopper. Okay. Once we are loaded in the hopper, we start the blade. Okay. So the blade which is connected to the motor. Okay. So once the motor rotations, the blade also rotated. So over the blade we can fix the heater on the both side. Okay. Once the motor started, the screw will move towards the right side, from left to right side. Okay. So simultaneously we are applying the heat also. So the granules will move to here to here. Sorry. From here to here, the automatically based on the heat, will reflected from here. So the granules will liquid state, transfer to the liquid state based on the heat sources. Okay, so here the liquids, once the converted into the liquid state, so they are automatically the liquid thermoplastic material collected in the before to the injection area. Next we are going to apply the pressure. So which means from the left side to right side we are going to apply the pressure. Automatically the liquid thermoplastic material will flow through the nozzle to the die. So the blue color is the die. Okay, so here we are applying the old water and it's a water outlet because the molten stage thermoplastic have some heating nature. So we can control the heat nature through the water. Okay. So next, so this is the E. So the E is one of the recent advanced manufacturing material, which means so 3D printing materials. So this is a tool, which means this is a die. Before the die, the material. So the material, raw material nature is we are applying the material through the wire. Okay, so based on the wire we move to left side to right side. Parallelly we are applying to the heat. So based on the wire as well as heat, the material will deposited over the die. Okay, so finally we remove the die after we get the material. Okay, so this is a material deposition method. So first layer, once we completed the first layer, again the second layer deposit over the first layer onwards. Okay, next the third layer will deposit over the second layer onwards. So these are all the fabrication method of composite materials. Okay, so next once we develop the composite material, next go for the properties for checking the prepared composite materials. Okay, so here we are going to conduct the two kind of testing methods. So one is a destructive method and another one is a non-destructive methods. So mostly the non-destructive methods to confirm for the internal voids or blowholes available present in the fabricated composites. So the destructive testing means we can measure the capable of the composite. So particular composite, how much stress it withstand the developed composites. So in the destructive testing, we are classified into 5 categories. So first one is a mechanical and physical testing, and the second one is a electrical testing, and next one is a chemical analysis, next one is a thermal, and last one is a heat and flame testing. So if we are discuss with these 5 categories, it will take a long time. So crisply I will complete it within the very short time. I will discuss only about the mechanical testing. Before going to discuss about the mechanical testing, so see some of the advantage of the composite material: high strength to weight ratio, which means very less weight withstand the high strength compared to the metal materials. So compared to the composite and metal, so metal it's also resist the high strength, sorry, high stress, but it have some high weight. But the composite materials is very less compared to the material. It also resists the high stress. Okay, so these are mostly interesting of key point of composite materials. And some other fatigue and corrosion resistance also, anisotropic materials and tolerable properties based on the constituents. If suppose I need thermal resistance material, we can able to add some thermal resistance material into the composite materials. We can able to control the chemical means I will add or I will coat on the particular composite material. So these are the possible way of to achieve the particular composites. So these are some examples how to do the mechanical testings. So these comes under the destructive testing materials. So see the first one. So this is a compression molding method. So see the bottom plate. So this is a bottom plate. This is our down produced composite material, and this one is a upper jaw. Okay. So this upper jaw is a movable one, and the bottom jaw is a fixed one. Instead of these two jaw, we are going to fix the sample. So once we start the machines, the automatically the load will apply towards the bottom side. Okay. Here we can fix the strain gauge, and stress strain automatically developed through the computer. Okay. See the tensile test. So second one is a tensile test. Here this is the same also. Here we have a C type of a gripper, because the sample will hold on the gripper. Okay. Here also the bottom gripper is fixed and top gripper is movable. Okay. So here the applied load towards the bottom, here the applied load towards the top side. So based on the applied load, the sample will be elongated. Okay. So based on the elongation, how much the sample is elongated. So these may be calculated through the systems. Okay. So next one is a flexural, sometimes called as a 3-point bending. Okay. So two supporting columns. Placed over the samples on the two supporting columns. So next the round type of nose radius will apply the load towards the bottom side. So here is maximum contact of the material is high, but in here the maximum contact of the material only these column only. So how much material will bend or reflected based on the applied load. So this is calculated based on the applied load and how much percentage it may be bent. So these two categories also calculated from the computers. So here we are going to follow the ASTM standard D3039, and compression testing we are going to follow the D3410, sometimes D6641, and flexural test D790. So what is the ASTM standard means? So all over the world we are going to follow the same testing methods for composite materials. We can use the ASTM. For example, I develop some composite materials in India. So I am going to follow the same ASTM standard 3039. Some other people develop some composite materials in Pakistan or Europe. Those people are followed the tensile test through the ASTM standard 3039. So this standard is especially specific for composite material tensile studies. So next one is a compression test. So compression test ASTM standard is 3410. Like the way, so each and every test have some ASTM standard. The ASTM standard is explore the how much strain rate will give, how much dimensions of the samples, how much, what are the procedure to conduct the tensile test, to conduct the compression test, to conduct the flexural test. So all the cases include in the particular standards. Okay. So next one is a impact test. So in the impact test classified into two categories. One is a ISER and another one is a CHARP. So what's the difference between the ISER and CHARP means here? So this is the example of Charpy impact test. So the sample is loaded in the horizontal way means it is a Charpy impact test. Suppose the sample is loaded in the vertical manner means so that test called as a hazard impact test. Why we study impact study means if you if you manufacture the bike or a car, the industry, most of the automobile manufacturing industries are after the productions of bike or a car, the people are trying to study the impact study. The impact study is nothing but sudden load act on the particular sample. Okay, so I prepared some composite names. So same study also conducted in the laboratory level. So some other sudden load act on the my prepared composite, how much resist particular weight, particular velocity. So these kind of studies study in the impact tester. So next one is interlaminar shear test. So this purely on different stacking materials, CV composite materials. So the second case, so this image is interlaminar shear test. Okay, so I made some different stacking material composite means. So the different stacking material, how much the interlayer bonding strength. Strength we can able to study through the interlaminar shear stress. So next one is a fatigue study. So the fatigue study is one end is fixed to the motor and another one is next to the movable jaw. So this may be transfer fatigue or it may be a rotations fatigue also available. So this is a fatigue study. So next one is the comparisons with the conventional materials. So more or less the composite is high strength equal to the metal materials and also equal to the polymers and equal to the ceramic thermal resistance. Okay. So next one is the composite of the design flexibility and the tailored performance. So corrosion resistance is fatigue is superior for the protected produced composite also. So these are also recent developments. So one is a biocomposite, and another one is a nanocomposite, and another one is a recycled thermoplastic composite. Next one is a hybrid composite, and last one is a smart composite. So biocomposite is nothing but renewable natural materials. We are using the reinforcement maximum materials, both reinforcement materials and matrix materials. Next one is a nanocomposite. So recently the carbon nanotube is more and more attractive for all the domains, as well as graphite is also equal to the carbon nanotubes. I saw one of the example of graphite sheet. So it's a very quite thin. It may be a 2 mm, it may be a 1 centimeter or 2 centimeter thin material. Above the thin materials, you have a big elephant. Okay, so imagine we have a big elephant placed over the thin sheet on the graphite sheet. So the graphite sheet will resist on the particular elephant weight. So this is one of the example of graphite strength. Okay, so next one is a recyclable thermoplastic composite. Okay, so everyone know the plastic drinking bottle. Okay, after drink the water, we can throw the PET bottles. So after collecting the PET bottle, I have some research about the PET bottles. Okay, after throwing the PET bottles, I have made plastic tiles from the wasted PET bottles. I have registered my pattern through the Indian pattern also. Okay, So next one is a hybrid composites, so combined benefit. So which means I can improve my corrosion, normally I can improve my thermal resistance. Means I have ordered the composite materials through metal matrix and as well as ceramics materials into a single composite. This is one of the possible way to develop the composite materials. So next one is smart composite. Smart composite is recently working on all the domains. So one of the self-healing is the best example, our human body. Okay. So if any place you have some wound, okay, you will wait 2 or 3 minutes. Automatically it will close to the wound. Okay. So this is the example of self-healing. Okay. So like that way, the composite also have some healing materials. So we can add the particular healing materials, means the composite also automatically heal to break, to resist the break, resist to the crack initiations, resist to the crack propagations. So everything controlled through the self-healing. Okay. So next one is the same memory. So based on the temperature, based on the cooling, we can control the. I have some temperature, but I need some cooling. Means we can use shape memory. Means from the temperature is one of the output from some other source. Okay, but I need some cooling from the temperature base. Means I can use some shape memory. Okay, so this is a small example of shape memory alloys. So next one is the sensor integrations. So if it is I already told the graphics, simple example of elephant weight, it resists some elephant weight. So CNT and graphene is most expensive, not the most expensive, it is nanomaterials mostly used in the sensor integrations. So see the some examples of composite materials. So in the aerospace materials, the aircraft wings and fuselage and interiors component made with the composite materials, because we can achieve some low weight. If suppose high weight, suppose if you are using the metal as well as magnesium as well as some other metal, you are using this aircraft wings, fuselage, interiors, we can't achieve the efficiency on the particular aerospace materials. Next, automotive materials. So the pumpers and the hoods, so front hoods and EV battery enclosures. So all the case covers cover through the composite materials. Next one is sports. So this rocket. So the outer layer of the bed made with the composite materials. So next one is a marine. So boat hulls. The boat hulls is naturally available in the back side of the, or sometimes available in the front of the marines. So because if you are using the metal materials, means the particular material connect with the sea water. So the sea water have some sodium chloride. Okay. So if it is the metal material continuously contact to the sodium chloride, means automatically 1 or 2 years it may be eroded. Okay. So if you are using the composite material, you can control the corrosion materials through some other ingredients materials. So the boat hulls also developed with the composite materials, and also propellers and also panels. Okay. So next one is the construction. So bridges and columns and wall panel also developed with the composite materials. Thank you for your questions.